Welcome to the fifth episode of BC Under the Hood. So a while ago we had another episode where we talked about how many users can Business Central handle in the cloud. And what we said back then is there are a lot of resources in the cloud, a lot of compute and a lot of database. So Business Central can actually handle many users, providing we write good AL code. So we are going to talk about performance today, and we are going to talk about how to write super fast AL code. My name is Vincent Nicolas. I am the Chief Architect of Business Central, and today with me to talk about performance, I have invited Bardur.
Yeah, I'm Bardur Knudsen, and I have been with the product for many years. I started writing AL code in C-side, and now I'm part of Vincent's AL architects, or app architects.
So actually, when you started, it wasn't AL back then, right? In C-side.
It was CAL.
It was CL, right?
CAL.
Yeah. So you have been working with the base app for many years.
Many years.
Right. So Bardur, what can happen in AL code? How that will affect performance?
Yeah. So now that we talk about performance, I think we should take a look at how fast is it and where do we spend our time.
Mm-hmm.
And a few years ago, I did some measurements. So executing a line of AL code or a statement that doesn't look up in the database takes approximately a microseconds. That means 1 million lines per second. That's really fast. And these are even advanced statements like calculations or assignments or Then we have SQL calls, and at best they are 1 millisecond. Often it's seconds, full seconds. But even a millisecond is 1,000 times a microsecond, right? Mm. Then I also looked at our code, and the ratio between database statements and non-database statements is approximately 10 to 1. If you combine these numbers, it means that basically the NST spends 99% of its time just waiting for the database to return with a result.
So that way the time goes.
Yes.
So that means it's quite important what's happening with the database.
Exactly.
Right?
So it's all about database access. That's the only thing we really care about. Actually, we have some automated tests where we compare version to version or even build to build as the project goes forward. And the only thing we care about there is the number of database calls, because the timing can vary for various reasons.
So you actually count how many database calls.
Yeah, and we can do that with the performance toolkit, which we encourage people to use.
Mm. So also partners can do that with.
It's not only really accessible, and it will show you both timings, which obviously users are interested in, but also the number of SQL statements.
Mm. So now database is where most of the time goes.
Exactly.
Right?
So any good or bad code has to do with how well do we manage our database access.
So we talk about. So one of the things we're talking about, we talked about in this previous episode was long-running queries.
Yes.
How long does a query have to be before we categorize it as a long-running query?
Yeah. So. Well, we say when it's longer than 750 milliseconds, then we define it as long enough to be interesting for us to log, and then we log in there.
So anything that takes less than 750 milliseconds, we consider normal.
Yeah, we are blind to that, I would say. But what is long? What is expensive? A bread can be expensive and a car can be cheap, right? Even though it's completely different.
Yes. Yes, it depends what you do.
Exactly.
If you do something very complex, maybe it's okay.
Yeah, exactly.
Like you do complex report or something. But some other operations can be considered maybe more, should be immediate from a user standpoint at least.
So generally speaking, the more often you query the database, obviously, and the more time the database needs to spend reading data or fetching the data. Mm-hmm. The database is like a librarian, right? Go and fetch stuff for you.
So what can we do about long-running queries? Let's say we detect a really bad one, like several seconds, or even sometimes minutes. That can happen too.
Yeah, That's
So
where
what can we do about it?
We can first of all look at indexing,
Mm-hmm.
and first of all we need to detect it.
Yeah.
And that's where telemetry comes into play. Obviously, we have a lot of customers we can look into in telemetry for.
Mm-hmm.
But as partners, you would have app insights,
Mm-hmm.
where you can at least look at your customers. But also, if you have a specific customer complaining about a specific case, then you can go and investigate that, both with app insights, but also with some of the tools that are built into the product.
So index optimization.
Index optimization and
But first of all, detecting that's the query that
yeah, I mean,
understanding that the query is taking time, and then we can do indexing that there might
yes,
be missing indexes, for example.
that's one thing, but also the structure of the code.
Mm-hmm.
How often do we actually have a slide?
Yeah.
It shows something here. So here I have a slide that shows you ways to minimize the number of queries.
Mm-hmm.
So for instance, nested loops, you loop over all customers, and for each customer you do something, look something up,
Mm-hmm.
or if it's posting a lot of sales invoices, you do a lot of stuff per sales invoice and per sales line.
So what you're saying actually is that, if I understand correctly, one thing is queries, which you can do one single query,
Yeah.
which will take a long time,
Yes.
which is bad.
Yes.
But also you can have many smaller queries that, even though they don't take a lot of time,
Yeah.
they might be, for example, in loop or
Yes.
even nested loop, as you
Yeah.
mentioned, right?
Maybe it's a bad analogy, but think of you go to a shoe store,
Mm-hmm.
right?
Yeah.
And you come in, the exact pair you wanted in the right size are there on display. And you take them and you're happy. That corresponds to hitting the NST cache, if you will.
Uh-huh.
Right? The NST already has it there.
Yeah.
Here you go.
Uh.
The next level is you say, could you go and fetch a pair of these for me in my
that
size,
yeah.
whatever, 43,
Yeah.
4. And then the clerk goes off,
Mm-hmm.
comes back, and you try them on and say, not quite, right? And off he goes again. Or, so that's one, that could be multiple queries, right?
Mm-hmm.
Or you upfront say, I'm interested in these 3 pairs,
Mm-hmm.
and I'm not sure whether my size is 40, 2, 3, or 4.
Mm-hmm.
Could you go and fetch all for me?
Mm.
And then it will go off and take everything back. Of course,
Mm-hmm.
he will spend more time on storage, but
All in
at
all,
least
it's going to be faster.
exactly.
Yeah. So each round trip actually is
Round trip
costly.
is one of the bad guys here.
Yeah. So we want to avoid having many round trips, for example, in the loop.
Yeah, exactly. And that's where we can use queries, because that can do combine the loops, if you will, and it can do summarizations and all sorts of good things for us. The other thing is we can use flow fields, which is also kind of an old-fashioned
That has been around for a long
query.
time, right?
Is it, yeah, forever almost.
Yeah.
So for instance, you have look something up and you want the sum of all underlying entries.
Mm-hmm.
That's typically a flow field. Or if it's an entry, you may have the account name or customer name as a flow field, a lookup flow field.
Mm-hmm.
And you can ask SQL to calculate these instantly. So,
as opposed to doing it in the code.
Yeah, exactly. Instead of doing it afterwards with calc fields. And
So basically, the strategy you are describing here is to push as much as possible to SQL.
Yes.
Because SQL is quite good at doing this kind of thing.
SQL itself is blistering fast.
That's what SQL is. It's
exactly.
It's very good at doing this kind of
Yep.
operations.
I mean, the biggest companies in the world run on SQL servers. It's not because it's slow.
Right.
Right.
So it's better to let SQL do that kind of thing,
Yeah.
aggregation of calculation of fields, that kind of thing.
Exactly.
Rather than trying to do it in the L
exactly.
code.
Yeah. So that's one thing, and the last thing is a smaller thing, but we can use the function called setload fields. So some of our records are very large, and even some of them have extensions.
Mm-hmm.
But if you're only interested in, I don't know, a posting group or a currency code for a customer, you don't need to read the entire customer record with all its extensions. You can ask SQL only go and fetch that currency code.
Instead of returning the entire...
Yeah, and having to do joins and everything with...
And,
exactly.
Yeah.
So that's also...
Yeah.
something we can do, it should do.
So how can I? So you gave a few examples of how to write better code here, faster code. So how can I? Or can I do a baseline? And what's the best way to figure out, how much that helps? So can I do a before and after comparison of my code? Like, let's say I've written a piece of code that I think doesn't perform very well, and I suspect it's a database, and I follow some of your recommendation, maybe do some optimization, indexing, or whatever. And
So the performance toolkit I mentioned before obviously can help you simulate.
That's the tool for that.
One tool. Obviously, you can also, if you can repro it locally, then you have access to the database SQL tools like Profiler.
So how much, talking about which, how much, if I'm a developer, a BC developer, how much do I need to understand, how much knowledge of SQL do I need? How much to understand how SQL works? And because if I just write a code, I don't see the queries themselves.
No,
per se, right?
Exactly, and this is where I also come to something else that's fundamental. I mean, ideally, AL is, in theory, agnostic to SQL because our statements are, we have get and find set and stuff like that.
You don't write SQL language in AL.
Exactly.
As such,
exactly, and sometimes that's a good thing, sometimes not. But it's really useful to understand at least the indexing part. And
so what happens under the hood, basically, when we compile AL and the runtime, we actually do generate somewhere. We do generate a SQL statement, right? But you kind of never see it but that's what's happening.
Exactly.
Somewhere. And when you write a get or
it's
or
even better than that,
something.
actually, because even before issuing a SQL statement, the NST will see, do I already have this data in my cache? So typically for when you do get some setup
Customer
or get this customer or something, if it's popular enough, it will be there in the cache. So it will be an in-memory operation, which is close to instant. But otherwise, whatever we write is transformed into some kind of SQL. And this is also a place where we optimize over the years. Also, as SQL becomes more and more advanced, we try to adapt that and uptake new SQL features.
So the first time you would read a record or set of records, that would be maybe a little bit slow.
It will at least take a millisecond.
And then we will have it in the cache.
Yes.
If there's all the subsequent requests who are requesting same data will be very fast.
Yeah.
So that's maybe why people that is why people are experiencing sometimes when you just log on in the fresh instance of and nobody else has logged on before.
And what's more, it's not just your session, it's the company's session, right? So if none of your colleagues, if you're the first Monday morning, then you get to load everything into cache.
So so the advice is don't come too early at work.
Exactly. Monday you should start at 10 before.
Like after everybody has actually hydrated the cache. Right?
So that's all caching, obviously. Also metadata and pages and what have you. For what they need, I have another slide here actually. Because when you retrieve data from the database, obviously it has to do with the amount of data. The bigger the table, the more records, the longer it takes. So there are like 4 levels of fetching a record. One is what we call primary key lookup. That's like the get, get this entry with this
like
number.
The pair of shoes that you get
exactly.
right away
almost. So that's as fast as it can get because The next one is what we call index seek. So it's number, whatever, 1, 2, 3, or it is. And then the seek will go and find a perfectly matching index and find it exactly and see, it's located there, and then it will read it for you. The third level, which is not good, is that the field is in an index, but it's not in the beginning of the index. And the only thing SQL can do then is it has to read through the entire index, which can be millions of
if it's a large
nodes. I mean, for all entry tables, it will be millions. That's really bad.
So how can we avoid that?
Yes and no. Yes, of course, we can just add an index for that field. But sometimes some customers want to search on all sorts of fields, and we can't have an index for each field.
Yeah, because index are also a little bit expensive, right?
They are expensive both in maintenance, but also in volume. I mean, database, disk space.
So is that fair to say also that, as a rule of thumb, indexes are helping for speed, for retrieval of data?
Yes,
but
it's
when
almost
we insert new data, it's actually a little more expensive than if you don't have an index, right?
Yeah,
Because you don't only insert the data, you also have to maintain the index at the same time.
Exactly.
But that's kind of a price to pay to get a fast retrieval. Later on.
Yeah, I mean, in that sense, it's exactly like a book or an encyclopedia, right? With a lot of articles, you need to find an article about whatever, and if you can, in alphabetic index, find it quickly, it's fine. If it's not sorted alphabetically, then you would need to go through the entire index to find it. Right?
Which obviously takes a longer time.
And the worst is if there is no index, then you need to read the book, or at least browse the book, which corresponds to the fourth case where we have a table scan.
Okay, so full table scan is the absolute worst.
That's the
case.
worst.
Yeah. So when does that happen, typically?
That happens typically, I mean, obviously when we don't have an index, but it also, most people experience it when they use the, in a page, list page, in the upper left corner.
Upper right, you mean? Whatever.
This is left for the viewer.
Okay. All right.
Right. There's this page search field, right, where you can enter stuff, right? I want to find Vincent, right? Made my custom list, but since I have 1,000, not 1,000, maybe 1 million customers in the list, and the page search actually searches on all visible columns.
Okay.
Except for numbers and booleans and stuff like that.
So
but they will search the name field, they will search the address field, they will search, whatever, city field. And the only way the SQL can handle that is by actually reading through all 1 million customers. And that takes forever, which people have.
That explains why this feature is particularly slow.
Yes.
And does that also, so when a user does that on the system, do a search like this, does it actually impact other users in the system?
Yes and no. Only, not by locking or anything, but of course it takes some resources away from SQL, right?
Yeah, we'll get to locking in a second,
Exactly, right? Because SQL needs to spend time reading the entire customer record or table.
So we're using, so that one user is going to use some of the database resources, right?
Yes.
Some database computational resources to do that search. So that could explain why other users find the system slow while SQL is searching, right?
Especially if several people are doing this at the same time, as they typically would in a system.
So don't come early in the morning and don't use the system while somebody else is searching.
Yeah. Or instead of doing a page search, if you have a lot of data, maybe use the column filtering. If you know it's the name, then at least you can filter on the name and say, I want to find Vincent in the name field.
Yeah, so that helps
which
a
is
lot.
Indexed actually,
that helps a lot.
On the customer.
The last thing I think we want to spend a bit of time on is locking.
Yeah.
Because that's also one of the, as we talked about in the other episode, that's also one of the things that can create some perceived bad performance on the system. So tell us a little bit about it. What is it? What is locking? When does it happen? What triggers it?
Yeah, I mean, locking is a good thing as such. It's a good feature that SQL has invented.
Why? Why? It doesn't sound good. Like, why would I lock something?
So,
right?
If I want to update some stuff, I may want to say, nobody touches this and nobody touches this until I'm done, because otherwise I get an inconsistent transaction. Right?
So, for example, just to say, if let's say I update the customer address.
Yeah.
So I first update, say, the street name.
Yeah.
And then afterwards I update let's say the postcode and the town. You don't want somebody fetching that record before I'm done.
Exactly.
Updating. Otherwise, I would have like the new address, the street name, and the old postcode and town name.
Yeah, exactly.
And then a totally wrong address. So
Absolutely.
that's a corrupted data.
Yeah.
So that's why when an operation like this happens, we need to kind of lock that record for a while.
And in particular, when we get into posting stuff or bigger updates that will come to in a bit, we really want to make sure that this transaction is consistent. So as such, locking is a good thing. But we also spend a lot of time looking up stuff and calculating stuff and looking more stuff up and writing log entries and doing stuff that we should do before we actually start updating the let's say the shared resources. So a good pattern is to do all the expensive stuff first, and then at the very end do a quick update.
So
or as quick as it can get.
So I was going to ask you about this because you discovered quite recently or a while ago you discovered that in our application there are many places where we don't quite follow that pattern, right? Where we take a lock on some of the data very early in the process.
Yes.
And in effect, that means that a lot of users are potentially waiting.
Yes, I mean, we can take a look at the sales order process posting because that's like our canonical example always we use. And if we look at what happens when we post a sales order, it's like in two steps. First, you do some internal calculations, calculate discounts and tax and stuff like that. But then we go and fetch a number from a number series, which is a shared resource, and then we commit. And then we remember this document number we got. Yeah. And then we start creating or going through all the lines, posting to inventory and resources and what have you.
And during all that time, so what is locked during that time?
Yeah, so that's the problem. Because we don't know if order A has something with items and then resources and then something else, or another order has resources, items, something else, and we don't want deadlocks.
Right.
So just to be sure, we take a semaphore lock, if you will, basically locking the system out for anyone else. I mean, when it comes to posting.
So just that table, or how much do we actually lock in that process?
From then on, we lock only what we need, but the problem is that this is a semaphore lock. We're saying now we are alone in this big room. Okay. Nobody else can come in here.
Everybody. We close the door. Nobody else can come in.
Exactly. This is a supermarket. Only I can be in the supermarket at the time until I'm done. What we really want, obviously, going forward, is to allow more people in the supermarket at the same time, if you will, right?
Yeah.
But if you look at what happens, is that we spend short time, maybe 10% of the time doing what I said first. Then 90% of the time is, what we call the actual posting, where we lock everybody else out. And this may not be long. This might be 1 second or 5 seconds, which is not long. But if several people post at the same time, user number 2 will have to wait the 5 seconds until the user number 1 is done, right?
Yeah.
User number 3 will have to wait
5 plus 5.
5 plus 5, and that's this very quickly compounds.
So it's like standing at a queue to get back to your supermarket.
Exactly.
Analogy, like if you have 10 customers and they all take 10 minutes to go through the cashier,
exactly.
You have to wait, the number of customers times 10 minutes before you get served, right?
Exactly.
Yeah.
So this is how it is now, and obviously we want to get to a situation like this where we actually can do things at least more in parallel. I mean, things like getting a number sequence might be serialized, but that's like a few milliseconds, so we don't care about that.
Yeah, because the code itself, the code itself, in theory, could run in parallel.
Yes.
Like technically, there's no reason. I mean, it is a multi-user system.
Exactly.
It is a parallel system. Right?
Yeah, I mean,
we have several processors in the machines, so exactly. We have technically it should be possible to run some of these things in parallel.
And most things are actually concurrent because you can have 5 users editing 5 different customers at the same time, or 5 other entities, so hundreds. I mean,
Yeah.
as long as we don't go and touch the same
Right.
data item at the same time. So it's not only about being in different tables; it's also about staying away from each other's records.
We do also have a log, a page where we can see all the logs, right?
Yeah.
In the products.
Yes, we have a number of very good tools. We have obviously the database logs page that shows what happens now. Then we have the missing indexes page, which shows SQL suggestions. We have the in-client profiler where the user can record an action and get a profile. And then we have application insights. And these are all well documented and displayed elsewhere. But specifically for the in-client profiler, I'll point to that you can download the profile file and open it in Visual Studio Code and get very nice overview of where time is spent. It's a huge helper when you analyze customer cases. Actually, recently we have got some new features. So if I, as a developer, as I said in the example before, I can use the new read isolation feature.
Okay.
So even though, where I'm called from, the customer may be in a locking scope, if you will, I can say, now I want to read the customer record without locking, only reading committed data or uncommitted or whatever. That's maybe not a game changer, but at least it will.
So that's the feature we introduced already a while ago.
Yeah, it was in 22 maybe.
Yeah, we'll put some links in the description
exactly.
and of documentation of these features.
So that's something we really we and partners need to uptake where relevant.
Yeah.
But that is game changing when it comes to making the system concurrent,
right,
if you will.
So let's get back to the tools. We're saying we have some tools for some help for preventing locking.
Yeah.
Or
so
at least finding diagnostic, troubleshooting and preventing, right?
Exactly. So Christian in a similar talk last time actually mentioned all of them.
Yes.
Or most of them.
Yeah. But maybe we can recap.
I'll recap them, and I have them here.
Yeah.
So we have the database logs page, which shows you who is locking now. The problem for me, if I were a partner, is that the customer calls, complains, but I may not have access to his system, and I can of course instruct him to go and look.
Right.
But by then the logs may be gone, right? So it's only interesting when it happens.
So you need to have some access to the system for to be able to see that page, right?
Yeah, and you need to look at it when it happens.
Yes.
Afterwards, it's gone, right? It's like an accident that's over. Yeah. Then Christian also mentioned the missing indexes page, and that's statistics, if you will, because different customers have different data distributions and different patterns. And
so this is actually a feature of SQL, right?
It's a feature
that we are surfacing into AL.
Yeah, exactly.
So SQL has the ability to monitor the queries that are performed.
Yeah.
And sometimes we don't know all the queries. We know the queries from our code, from the Microsoft code.
Exactly.
But there might be usually a set of extensions or the solutions on top. Some queries we don't know about, which we cannot optimize upfront for.
Exactly.
And SQL has this feature where it monitors what's going on in the system and can advise.
And what's even better or more is that we collect data from all the SQL servers, all our servers, and combine it into a dashboard, so we can actually see combined which indexes are missing most.
So you can actually get a recommendation coming from other systems.
All our systems and all our customers, right? Which is way better than looking at one specific customer. Obviously, as a partner, you would look at your customer, right? And optimize it for them. But we as Microsoft need to optimize for
everybody,
everybody, or the average, or the 80% or whatever. Then we have the in-client performance profiler, which is a gem that I think many people are not looking enough at.
Yeah. Yeah, we can see that in our telemetry that we don't have a lot of usage of it.
And I will in a second.
That's why we keep advertising for it. So please use it.
I'll show you why you should use it in a second.
Yeah.
And then obviously application insights, because that's where you can see long-running queries. You get the call stack. You can see exactly, what we are trying to query and whether it's locking or not, and so on. But to get back to the client profiler, in there, you can actually download a profile file, that you can open in Visual Studio Code. It may need to activate some feature or I can't remember, but
we'll
at least you can
again put some links into the documentation.
But the point is, then you can get something like this, where we're running a report, and for some reason it takes like 16 seconds, I think it says here, on after get each row.
So that's a very long.
That's extremely long, right?
Yeah.
And then you can see, okay, there's a function that spends 8 seconds itself, but then the other 8 seconds are distributed, and then you can see, okay, you can pinpoint exactly which 3 or 4 functions I want to look at, and then you can go look at your code.
So in that case, the 8 seconds function is probably the one you want to look at.
Yeah, or all 4 of them. We don't know. But the point is,
you can go all the way to the code, right, with this tool.
Yeah.
And pinpoint the exact line of code almost that is.
Function level, but even so.
Function level.
Yeah, but even so.
Down to the function. So.
Yeah.
So it's you know that.
But even so, this is a gem. I mean, use it. I would say.
All right.
Together with App Insights, obviously.
Yeah. All right. So what? Do we have any new upcoming performance improvement or tooling?
Yeah.
Or, what that can that we will soon be releasing. Or can you tell us something about that?
Yeah. So one of the big blockers we have is if we go back to the posting.
So you have been working on that recently.
Yes. Yeah. So if you look at entries, typically when we create ledger entries, GL entries, warehouse entries, whatever, we have a pattern where we basically lock the table, and then only I can add to this table. And of course, it means that all entries are coming in nice buckets.
And when you say we, you mean in the base app?
In the base
Microsoft
app. Yeah, in the base app.
Yes, Microsoft.
Yes.
Yeah.
So what we do is, most partners know all this already, but we go out, find the last entry, and then we just count up one, right, to create new entries and insert. And while we do this, we're locking the table. And I have a picture here that kind of illustrates that we have some warehouse entries with different colors that belong from different transactions that are linked to the warehouse register and are color-coded. What we want to get to is to use number sequences as the generator for entry numbers. We could also have considered using auto-increment, which I guess most partners are aware of as well. But the basic point is that by using some kind of non-locking assignment of entry numbers, whether be it number sequences or auto-increment, we can actually have several users creating transactions at the same time.
At the same time, yeah.
And as illustrated on this picture, there will be some mixing of the entries.
But that's maybe okay.
That's fine. Maybe not for GL, because some country there are all kinds of legislations, but all other tables, who cares? So for BC25, October release, we actually have done this for warehouse entries, and which means that from there we can have separate concurrent posting to warehouse entry, warehouse system at the same time. So people working in the warehouse can do stuff, even while the people in the office do other stuff. So
we talked about some of the scenarios where people have, for example, scanning
exactly
the barcode.
Yeah, exactly. All these
you get
scenarios.
Long response time, which is good experience, right?
Exactly. It's it must be horrible to be in the warehouse and your screen locks up, right?
So with that new feature, new improvement of the code, that should help, right?
Yes, should. But as I said, this is just the first step. We have a bucket list of entry tables we need to fix this before we can get to fully concurrent posting of sales orders.
So by the way, if you're interested in these changes, you can follow. We open source. We have open source app, so you can follow what's going on and all the pull requests that Bardur is doing around this. You can check this out if you should be interested in.
Definitely. In the warehouse register stuff, that's already there. So that's been there for I don't know, a month.
Yeah. So is there any other features we should look forward to, or other performance improvements or performance tools that are coming in the future?
Yes. So on a very short time frame, we are going to try to solve the issue of page search by introducing the SQL Server full text indexing, meaning that hopefully from BC25, searching in the customer list will be very quick. Also, items as well, obviously, but also when you are on a sales line and you start entering the item number and you get this drop-down list, that should be very fast as well. On a longer horizon, we think the concurrence and parallelization is the big thing to do, because that's the promise of the cloud, if you will. And often we focus on how long does it take to post a sales order. But that's not the issue, right? It doesn't matter whether it takes 1 second or 5 seconds. Because if you're going to post 50,000 of them, or adjust cost for 50,000 items,
it needs to be parallelized. Right?
You need to do that. And if you just cutting it in half, like 2 threads, right? It's huge, right? Or 4, or you can cut it down 2 hours from 8 by just having 4 processes. Is fantastic. So that's a path we are.
Some of the things we could look forward to.
And which we started with the warehouse stuff, right?
All right. Thanks, Bardur. So we hope that you got some hints on how to write super fast code. We try to give you some indication how you could improve your solution and your code. We'll put some links in the description about some of the things we talked about here, and we hope you enjoyed that episode. Let us know in the comments. Thank you for watching.
Thank you.